Hey, what's up, guys? Today we're continuing from our last video where we went over how to do induction when we're asked to prove that a given function is equal to some other given expression, and today we're going to look at another question of that sort. So in this question, we're asked to prove using mathematical induction that the following statement is true. So without further ado, let's just jump straight into the first step of induction, which is, of course, our base case. And it's important to first note that we're doing induction on n, which means that n is going to be the variable that we're manipulating. So that means our first step, which is the base case, sorry about that. The first step, which is the base case, is just going to be obtained by plugging in n is equal to 1 into the equation. And why n is equal to 1? Remember, we're using the lowest possible value of n, and n is defined as, sorry about that. N is defined as the set of all positive integers, so 1 is naturally the smallest positive integer. All right, so plugging n is equal to 1 back into this equation just gives us cosine theta minus I sine theta on the left-hand side. And on the right-hand side, we just have cosine theta minus I sine theta. So easy peasy. Oh my god. I sine theta. Easy peasy. Left-hand side is equal to right-hand side, obviously. And therefore, we've proved that the statement is true for our base case. And now we can move on to our next step. So our next step is the inductive hypothesis. Remember, that's where we assume truth. My pen is being super wonky today. Assume truth when n is equal to k. So what does this mean? Well, this just means that when we substitute n as k into our original equation up here, when we substitute n is equal to k, the resulting equation is going to be true. So let's substitute that right now. If we substitute n is equal to k, we're given the following equation. Cosine theta minus I sine theta to the kth power is equal to cosine k theta minus I sine k theta. So hopefully that's pretty straightforward. We'll move on to our third step now, which is, of course, our inductive step. And that's basically saying, well, if the statement is true for n is equal to k, what we need to do now is we need to prove that the statement is also true when n is equal to k plus 1. And again, what does this mean? Well, that just means that we're going to substitute n as k plus 1 in our above equation, the equation that we're... Oh, boy. We're going to substitute n as k plus 1 in the equation we have above. And hopefully that makes a bit of sense. And by substituting n as k plus 1, we're given the equation, cosine theta minus I sine theta to the k plus 1 is equal to cosine k plus 1 times theta minus I sine k plus 1 times theta. Okay, so remember that this is the thing that we need to prove. We need to prove that this is true. And we've assumed that this statement is true. So this statement is already true, all right? So what we need to do is we need to use this statement to prove this statement up here to prove that this statement down here is true. So how do we do that? Well, remember from last time I introduced a few tips. And if you haven't watched the last video, please go check it out. The link is in the description below. Wow, I feel like a real YouTuber saying that. Anyways, first tip is that we want to figure out what's the difference between these two equations, right? So what's actually going on what's actually happening when we go from this first equation, which I'll label as 1 up here, and the second equation, which I'll label as 2. Well, all that's really happening is we're taking the left-hand side and we're raising it to a power, right? So we're just multiplying this term by an extra cosine theta. We're multiplying this term, sorry. We're multiplying this term by an extra cosine theta minus I sine theta to get this term down here. We're just taking an extra power, all right? So the next thing we want to do is we want to write this guy over here in terms of this guy over here. And now that we know that, well, this guy over here is just this guy over here taken to how do you say, like, taken to a higher power by a degree of 1. It's really easy to write our expression we need to prove in terms of the expression that we have. All right, so what I'm going to do is I'm going to take the left-hand side, and the left-hand side is of the expression we want to prove is cosine theta minus I sine theta to the k plus 1th power. All right, so writing this in terms of cosine theta minus I sine theta to the kth power, we get cosine theta minus I sine theta to the kth power times cosine theta minus I sine theta. Hopefully this makes a lot of sense because we're just using exponent rules here. And what we can do now is we see that, hey, cosine theta minus I sine theta to the kth power, we've seen that before. What's that equal to? Well, that's just going to be equal to our guy over here. I'll circle it. It's just going to be equal to this guy over here. So what we can do is we can substitute that right in. So is equal to cosine k theta minus I sine k theta. I think that's right. Let me just check. Yeah, cosine k theta minus I sine k theta times cosine theta minus I sine theta. This is super easy to simplify. We're just gonna expand this out. Sorry, let me move down a little bit. Taking the first terms and multiplying them together, we get cosine k theta times cosine theta, right? So cosine k theta times cosine theta. Our outside terms are just I sine theta times cosine k theta. Our inside terms are just I sine theta, I sine k theta times cosine theta. And the last two terms are, well, negative times negative gives you a positive term, but I times I is obviously -1, right? Because I is the square root of -1. So the entire expression is going to be negative, and we're multiplying sine k theta with sine theta, so we get minus sine k theta times sine theta. All right, so now you might be asking, well, where do we go from here? Well, you might see that we can group some terms together, right? But realistically, on the IB diploma, you're going to be under a lot of time pressure, and you might not be able to see that you can group some of these terms together and use trigonomic identities. So what I'm going to do is I'm going to say, well, this is already pretty simplified, and I'm going to actually take a look at the right-hand side of the equation and see if I can do some manipulation to simplify the right-hand side and go from there. All right, so what's the right-hand side of our equation? Well, that's just simply, I'll use a different color. Why not? That's just simply this guy over here. So let's see if we can simplify cosine k plus 1 theta minus sine I sine k plus 1 theta. I'll use red. So we have cosine k plus 1 theta minus I sine k plus 1 theta. Well, one thing that we can do for sure is that we can distribute the thetas out, right? If we distribute the thetas with the k plus 1, we just get cosine k theta plus theta minus I sine k theta plus theta. All right, aha. And we immediately see what we can do here because we just have trigonomic expressions with two added terms. And so we can actually use our trigonomic identities, the ones that deal with addition, right? So we know that from the formula sheet that cosine, oh, I don't know what I did there. How do I get rid of this? I'm just going to nonchalantly move it to the side and pretend that nobody knows. Oh, there, it's gone. Oh man, sorry about that. Where were we? Oh yes, yes, cosine A plus B. That's just equal to cosine A, cosine B, minus sine A sine B. And we know that sine A plus B is simply equal to sine A cos B plus cos A sine B. So using these identities, we can simplify, sorry, I'll box this in a different color. But you know that these are the two identities that we're working with. Don't actually have to do with our equation. So using these two identities, we can simplify the equation that we have here. So cosine k theta plus theta is equal to nothing but, well, if we treat k theta as A and theta as B, cosine A cosine B is just equal to cosine k theta cosine theta minus sine A sine B is just sine k theta sine theta minus I wrote that on a new line. I don't know if I have room. Minus I sine k theta plus theta, k theta plus theta. We can use our sine laws, sorry, the trigonometry law for sine, and we can say that sine A plus B is equal to sine A cos B. And if we treat A as k theta, and we can treat B as theta, then sine A cos B is just simply sine k theta times cosine theta. And the second term is cosine A sine B, so that's just equal to cosine k theta times sine theta. All right, hopefully that all makes sense so far, and we're reaching the end of our proof here. Finally, we're just going to distribute the i's, so we're left with cosine k theta cosine theta minus sine k theta sine theta minus I sine k theta times cosine theta minus I cosine k theta sine theta. And if you notice, the expression that we have here, well, this right-hand side is actually identical to our left-hand side over here. Right, these two are actually the exact same. So then we can say that the left-hand side is equal to our right-hand side, and therefore we are done. And the proof is finished. All right. So I hope that this made some sense. I hope that you learned something, and in the next video, I'll be going over a new type of inductive problem. See you till then.